yeah, in this video we're going to go over how to add and subtract like radicals. I want you thinking of this as if we're adding and subtracting like terms, and I'll show you what I mean. So here we have the instructions to simplify, and we're told to simplify 5 times the square root of 2 minus 2 times the square root of 2. Well, if you read it as 5 root 2's minus 2 root 2's, because that's what multiplication means, right? You have root 2 plus root 2 plus root 2 added 5 times, and then you're subtracting 2 root 2's. Well, if I have 5 root 2's minus 2 root 2's, that leaves me with 3 root 2's. Quite literally, you're thinking of it as 5x minus 2x, which would leave us with 3x. It's like combining like terms. So when you have like radicals, meaning you have the same exact makeup, the same exact expression underneath the radical sign, underneath the square root, then all we're doing is subtracting the coefficients or adding the coefficients, just like you're combining like terms. Okay, let's keep going with this. So B, you have 7 square root of 13 plus the square root of 13. Well, that's like having 1 root 13. So if I have 7 root 13's and 1 root 13, that is going to give me a total of 8 times the square root of 13. And if you're looking at that saying, Mr. G, that's pretty easy. Is that all that's up with combining like radicals with addition and subtraction? Yeah, really. It builds on what you know about like terms. So what I did here is I put an expression or a term in here that is not a like radical to show you what we would do. So mentally what I'm doing here is I've got 9 times the square root of 5 plus 2 root 5, putting the like radicals together, minus 3 root 6. The signs belong to the coefficient that immediately precedes the radical, right? So the plus sign stays with 2 root 5 and the minus stays with 3 root 6. So 9 root 5 plus 2 root 5 is 11 times the square root of 5. We do not combine root 6. It's not like you do 5 minus 6 and get negative 1. Those are unlike radicals. We're done. That's as simplified as we can go. So this is a lot like if I were to have like 11x minus 3y. If you have 11 x's and 3 y's and you're subtracting y's from x's, you don't get xy's, right? That's as far as it can go. That's it, combining like terms. So sometimes I see problems like this where you have like 5, and we'll put a variable in there, times the square root of x plus 7 times the square root of x. Well, it's no different. You keep the square root of x, you have 5 root x's, 7 root x's, that gives you 12 root x's. Combining like terms, peeps, it's not bad. In a later video, we'll go over how to combine with addition and subtraction, radicals, when the radicals aren't in simplest form yet. Can't wait for that.